Yeah, and somebody just texted me saying they'll need the recording, so they will appreciate you doing that. So if this side is 180, it has to be 180. You just subtract and you get 71 degrees for this angle and this outside arc, which would make this one also 71 degrees. Now I need E C G. Um, well, now I know that 55 plus 71 plus this arc here has to equal 180. So this one I may have gone in uh, plus 71 plus 55 has to equal 180. What's 71 plus 55? So then the measure of arc FG plus 136 equals 180. Oh, 126 is what you said? Sorry. Subtract 126 from both sides. And this is 54. So now do I have all the information to find angle ECG? Yeah, it'd be 55 and 54 is ECG. So 55 plus 54 will give me that measure of angle E. Oh, am I going to have enough room? CG. So that would be 90, no, 109, right? Um, is the measure of angle ECG. Oh, my hand is hurting me today. Now, of course, that's in degrees. Okay, any questions on that one? So, big clue. There's not, like, I can't give you steps for these, but I can give you hints. You always want to look for what diameters because it cuts things in half. You want to look for vertical angles, right? And you know that the circle has to always add up to, the full circle has to add up to 360. So you have to use those pieces of information and kind of just puzzle it out. Yes. I was going to ask if it would be okay if you measured the angle and found that out. No, because a lot of times people will make sketches, but it's not drawn to scale. So in geometry, a lot of times you'll see things saying not drawn to scale, so you can't do that. You could, right? Just use a protractor and measure it out, but life would be so much easier. The measure of angle NIJ. So I'm looking for this one here. Do I have any diameters? No, there's no diameters. But you have all the information except for this piece here. So if I add all of these together and subtract it from 360, that's going to give you your answer, right? That the measure of angle N, I, J, plus all of these 90, 70, 55, 95 has to equal 360. So add all of these together and then just subtract it from 360. So, oh, thank you. So the measure of angle NIJ plus 310 has to equal 360. So this would just be 50, right? The measure of angle NIJ has to equal 50 degrees. So this would be 50 here. Because all of these added together have to equal 360. Any questions on that one? Sure. I can go slower.
I was just gonna say something. I
Sure.
remember like you saying at some point that this is like gonna sound weird probably, but I just remember at some point you saying like for us to circle the numbers on the outside.
Yeah, that was for. Do I have one of those on here? Yeah, that's for the when you're getting the perimeter. I don't have one on here. But these inside and outside arcs are central angle. These are central angles, and these two are always equal. Inscribed are different. That's when you cut it in half. But when they're coming from the center, then the arc it intersects have the exact same measure. So because you were just looking for this angle right here, but I had all the others, right? Let me erase this so you can see it. I have them all other than this one. You just add all these numbers together and then subtract it from 360, and that would tell you that this has to be 50 right here, which would mean this is also 50 for that angle measure. Does that make sense? Now over here, it was a little trickier, but you had to think about diameters, cutting the circle into 180 into halves, and then finding missing pieces. Any other questions on these first four? I don't want to go too fast. Good. Okay, now we're talking about inscribed angles. So this is an inscribed angle. How do I know it's an inscribed angle? This here, right? Right here is an inscribed angle. The vertex is on the circle. Where central angles, the vertex is from the center. Do you see the difference? These are coming from the center, but the vertex is on the circle itself. And for that relationship, this arc here is twice as large as the angle. So when I'm talking about from here to here, see this is where that angle ends. So let me highlight this one out here. So all of this would be the arc this angle intersects. Now granted, they want to know this angle. But I could find the other arc on the other side if I know this one, right? Because we know that it all has to add up to 360. So what's 121 times 2? This is 242. So from the major arc, and the major arc of KLM is 242. So now I can find the minor arc of KM by subtracting it from 360. So 360 minus 242 is what? 118. Now, so this is 118 on this side. So what do I do to 118 to find the angle of the arc that it intersects? Opposite, not 2 times, divide by 2. Because the outside is always double the inside. So if I divide this by 2, that will give me this degree here, which is 59 degrees. Oop. Any questions on that one? Okay. Oh, this one's real easy. I don't have to do anything fancy before. I just times it by 2 to get the outside arc. So this is 76. Would you stop? There. So all I did for 36 is 38 times 2, right? Okay, let's look at this one. This angle here intersects that arc KL. What would I do to 33 to give me this? Not divide by 2, because multiply by 2. So 33 times 2 is 66. So this side here, from here to here, is 66 degrees. But they want to know this side over here, 180. Do all like that I Spy. Have you ever played that with your kids? I Spy. Well, I spy a diameter, right? Here's the diameter. So this half has to be 180. And so if this is 66, the other one would have to be 114. That arc JK plus 66 has to equal 180. And so you just subtract the 66. Yeah, these are part of geometry, is to try to shore up your deductive reasoning skills. And this is where they do that. So this would be 144. Oh, 114? Where did I get 144? 114. I swore somebody hollered out at me. I guess I got to check everybody's work or verify. Okay, so over here, and I apologize. I'm getting a headache because my carpal tunnel's acting up. So, okay, so right now, any ideas on how to find this angle or this arc? Because if I have this arc, I know I could just divide it by 2 and it'd equal this. I'm going to add these two together. So that 140 plus 136 is 276. And that gives us most of the circle. Yes, if I subtract it from 360, I know that arc WX would equal 360 minus 276, which is equal to what? 84 degrees. Everybody agree? 84. So this is 84 out here, but that still doesn't give me this angle here. So I have to divide it by 2, which is 42, because I want that angle XYW would equal 84 divided by 2, which is equal to 42 degrees. So 42 degrees is your answer. So just to summarize again, full circle is 360. So I add these together. And then I subtract it from 360. It gives me this missing arc here. Once I have this arc here, I divide it by 2 to get the inscribed angle. Right? This one? Number 6? Okay, this is the inside. The arc on the outside is always double this one. Okay, so this one we divided because we were given the arc on the outside. But this is the opposite. We were given the angle, not the arc. So I multiplied by 2. Better? Okay, so this is an inscribed angle, which the relationship is this angle is always half the arc. These are called central angles. Notice they're coming from the center, so they're equal. Got it now? Good, 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 good. So this is a review of yesterday's work, right? Okay, number 9. Do I have a diameter? Yes, I see a diameter right here. PR is a diameter. So I know this whole side here should be 180. Now, I also have an inscribed angle, and here's the arc. It intercepts, right? Because here's the angle. And so this is the arc. And what's that relationship? What am I going to do with 60? Times it by 2. So 60 times 2 is 120. So this arc here, this arc RQ is equal to 120. To get this other side, you would do 180 minus 120 is 60 degrees. So this one over here is 60 degrees because this had to be half the circle. That's your answer. You like these? I like them because they're like a puzzle, but some students don't. Okay, now arc length. This isn't degree now. This is going to be if I measured this with a tape measure, or I put a piece of string around the outside and then laid it flat and measured it. And that's a formula. And the formula for the arc length is 2 pi r times theta. If you remember that, that's just the degree over 360. So if I'm looking over here, theta is going to be the 150. And what's the radius? Radius is 9. I'm going to use the pi button because I just know CUDA software tends to use the pi button, and pi is pi. So I'm just going to put it all in the calculator. And this is how we would put it in our calculator. 2, right, times pi times radius, which is 9, times theta is 150. Notice I did put a parenthesis. Divided by 360 and my parenthesis and press enter. And I'm rounding to the nearest tenth, so that would be 23.6. So is this degrees or inches? Inches, because this is a length. Okay, so what would I do for this one? 2 pi times 8 times 150 over 360. 2 times pi times 8 times 150 divided by 360. And that gives me 20.9 miles, which is be huge. 20 miles? That's long. And that's talking about this outside. Like if this was a pizza crust, right? That'd be how much the, boy, that'd be a big pizza. At my son's. Because I'll be sitting there watching TV. They'll make a full size pizza. And then they just cut the pizza in half. And then the other folds it takes half. Do you think they offer their mom any?
Oh my God. I thought mine was bad. Mine gives you the pieces and takes everything.
Yeah. I'm like, thanks a lot, guys. Okay. Sector. That's a different formula. That's talking about area. So this is the actual piece of pizza. So it'd be pi r squared times theta over 360. So you would do pi times 8 squared times 270 over 360. Oop. Oh, I can't do it. Yeah, so second pi times, it's a different formula because we're doing, yeah, we're doing sector. Oh, 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 oh. X squared, parenthesis, 270 divided by 360. And I get 150.8
Meter square.
meters squared because it is area. You guys are so good. You don't even need me anymore.
I
Pi
can't learn without you.
times, what am I going to put here? 13 squared times 225. Yeah, yeah. That's not too bad. So the second pi times 13 squared times 225 divided by 360. I'm going to press enter. And so that would be
31.8 centimeters square.
centimeters squared. Do, do, do. Very nice. Okay, so today, the type of theorems we're going to be doing kind of reminds me of what ophthalmologists do. Because, you know, when your eye is basically a sphere, right? And you'll see what I mean when we start talking about the formulas. Definitely want to use these on the test because sometimes I forget all the formulas. 4, right? 1, 2, 3, 4. Does that make sense?
Well, you guys are talking about your theme for your project. Right. But you may want to, because you have to get into something that's hard to find. Just art different.
Do you ever have been I got I think 100 on the I don't know how. Make sure that you have a timer next to you so you can watch your time. Get at least for 5 to 10. At least the bare minimum, otherwise they take a point. You don't say, It's okay. I was worried about it. I thought it was going to be worse, but it was. But after I was done, I go to the bathroom and cry. Yeah, I didn't know how I did, but some things I said, I crack a joke, make everybody laugh, and then I keep going.
Okay, so we're going to be we talked about lengths with secants, tangents, and chords, but we haven't talked about the angles. So we're going to define angles formed by secants and tangents of circles. We're going to use the theorems to find the arcs that are intercepted by these angles. So these are just different. Let me make this bigger. This is just showing you the different ways they can intersect, right? So this would be like a secant and a tangent. Secants go through the circles, tangents only touch the circle in one spot. This would be two secants. This would also be two secants. Here you could have two tangents. You can have two secants, a secant and a tangent, right? Okay. So this is what you want to look for to decide which theorem to use. Now this one we have been using because this is very similar to an inscribed angle. That this angle right here, that angle ABC, oh, I had my pen upside down, sorry. This angle right here is going to be half of this arc measure, and I'll do that in purple, of this arc measure here. That's all what it's saying. And it gives you the theorem right here. So it gives an example. It says find each measure, angle BCD. So here's BCD. What would I do to 142 to find this angle measure here? You divide it by 2. So that would be 71 degrees. So this would be 71 degrees. Now, do you notice that this one is pretty hard to see, but do you see a right angle for ACD?
Yeah.
ACD is a right angle, which is how many degrees? 90. So this little right angle means 90. And this is the arc it intercepts, right? So what is going to be ABC? What do we do to 90 to get the arc?
90 minus 71.
Nope. 90 times 2.
180.
Yeah, it turns out that that's a diameter. 90 times 2. That is equal to 180. Not all the time will it be. It's just because this is 90 degrees. Um, a diameter, you'll always see a center. So the first one we divided by 2 because we were given the arc on the outside, right? The other one, we were given the angle measure on the inside, so you do the opposite. You have to multiply by 2. Yes, this arc, A, B, C, that arc on the outside would be 180. Yeah, and that 90 was really hard to see, so I apologize. Okay, so now we're going to do a different one. So this one, where was the vertex? On the circle, right? On the circle. Here's the vertex. So now we're going to have a vertex in the circle. Do you see here how they're crossed and everything's in the circle? Okay. What they're saying is, and of course, these are vertical angles here. So it doesn't matter if it's this angle or this angle they're talking about because they're going to be the same. That if you take and add the arcs on the outside. So arc AB plus CD, and then divide it by 2. That's going to give you this inside angle measure. And here's the formula right here. That's probably on your notes. You want to star or highlight or however you decide to show that it's important. So if I'm here, what do you think I'm going to do to find this angle? Because I want SQR. What would I do? Yep, I'm going to add the 2 arcs together, the 100 and the 32, but then I'm going to divide it by 2 or multiply it by half. It means the same thing. Oh, I put the M on the other side. Give me a second. I wish I'd had an undo button. I put the M on the wrong side. Yeah, you have undo button up there. Where? Conclusion. See the conclusion? Your, right? I put the conclusion up yeah. There. Conclusion. Oh, there is a. Well, thank you. I'm still learning this too. So so SQR, right, is equal to 1/2 times 100 plus 32. Or you could put 32 plus 100. It's just addition, so it doesn't matter which way. So that'd be 132 multiplied by a half or divided by 2. It means the same thing. So, which is 66 degrees. Did we get those? Sometimes that's a little far down. Okay, so where was the vertex on this one? Inside. That's how you're noticing. Remember, this one was on the circle. No, it was on the circle. This one's inside the circle. And guess what this was going to be? Outside the circle. And you have 3 different ways that could happen. Mm-hmm. This is the one I think about the eyeball. Sometimes you see with eye top interest, sometimes you see like they'll have an eye here and then they're looking at that. So I would think that somebody who's doing surgery on eyes would have to know some of this stuff. Maybe. Maybe. Okay. So, what am I going to do for this one? Instead of adding, I'm just going to do the same thing, but I subtract, right? So, I'm going to have, here it has an x for us. So, x would equal 1 half. This one, it does matter which one comes first. You want to put the larger one that's on this outside first. So, this would be 174 minus 98. And then I would have, what is 174 minus 98? 76. And then I know I'll take half of that, which is equal to 38 degrees.
38 degrees.
Mm-hmm. I want everybody to pay attention to this next one. When you get into higher level math, these type of setups are you have to kind of look at things and be able to deduce and put these in. I only have one number here, but I need more information. What else do I know about circles? 360. So if from here to here is 132, I know that this side over here would be 360 minus 132. So this would be 228. Now I could do the problem, right? So I have x has to equal 1 half 228 minus 132. I'm running into my own other problem. X is equal to, what is 228 minus? That's 96. And now, yep, is equal to 48 degrees. So this is 48. And for people who wear glasses or should need glasses, I went ahead and made them bigger in one little summary sheet right here. Oh, sorry. Oh, he left, and I was going to give him these notes. Yep, 48 was the correct answer. We good? Okay, great. So on the, we just cut in half. In the circle, you add the two arcs, then multiply by a half, right? Outside the circle, okay, it's right here. It's on the summary. On the circle, right? All we do is do half of the measure. Inside the circle, we add the two together. Here you go, Brandon. Right? This is just a summary of what we just talked about. Right? Okay. Now, let's try some of these together. So, where's the vertex here for number one? It's outside. So, the outside, go look back at your, as we subtracting the two arcs, right? So we know that the measure of angle E is equal to 1 half times 133 minus 65. It's equal to, so is that the total answer? Okay, so 1/2 times 68 is equal to 34 degrees. So this is 34 degrees, right? I made it a little bit bigger for those in the back. What about number 2? This is inside. Do I add or subtract? So I will do, this would be angle, what angle is that? That'd be TRS would equal 1/2 123 plus 67. So that's 190, and then you take half of that. Very nice. Whee. Oh, is it 95? Why am I not hearing good? 95. Sorry about that. 95, not 85. That was my fault. Sorry. Okay, this one, where's the vertex? On the circle. There's a vertex. So what do? Just divide by 2. So 210 divided by 2 is equal to 105. So the measure of angle TSR is equal to 105 degrees. Okay, now those were straightforward, right? What does this one say? Spicier. Yeah, so these we have to think a little harder. Spicy. Okay, so in this case, we're given the answer, right? We have one of the arcs, but then we have a missing arc. So in this case, first of all, is this on the inside, on, or outside? Inside, which means we do what? We're going to subtract or add? Add. So I would do, I know 105 has to equal, because they gave us the answer, what it needs to equal. I'm just going to put an X here for that. 1/2 X plus 65. Now there's 2 ways to do a problem like this. I could get rid of the half right away by just multiplying both sides by 2, or I could do the distributive property and then work it out. Which way you wanted me to do it first? You want me to multiply by 2 on both sides? So if I want to clear the fraction, all you would do is multiply by 2 on both sides. What that does, this would become 210 equals, yeah, that just cancels out the half and the 2, and what's in parentheses you just bring straight down. I think this is the easier way, actually. So then you just subtract 65. So then x is equal to, what is it?
145.
145 degrees. I think that's the easier method.
No, I'm just messed up. You just messed me up.
Did you distribute the half?
Also, times 2 on each side.
That's one way to do it. There's another way to do this. This is probably the way you're used to it. So, and I don't care which way you do it. It's just this way you're going to get decimals. So if I use the distributive property, right, which that's probably the way a lot of you have learned, you would do 105 equals 1 half x plus what's 65 times a half, or divided by 2. 32.5, I believe. Uh-huh. 32.5. Then you would subtract the 32.5 from each side, and you would have 105 minus 32.5 is equal to 72.5, but you still have that half as your coefficient, and then you just multiply by 2. And then that is x is equal to 145. You get the same answer either way. This is just two separate methods. Now, many students from different countries do it this way. I've noticed that throughout the years of teaching adult ed, where for some reason in the States we tend to distribute the half. Either way works. I like this way because I don't get decimals, but does that make sense? Yasmin, here you go. Hmm? Yeah. Well, 1/2 is, if you remember, like one step equations, like x over 2 equals 72.5. This is dividing by 2, and the opposite of dividing is multiplying by 2 on each side. 1/2 times 2 is 1, so it just cancels each other out on both sides. You're clearing the fraction is what you're doing. But you could directly clear the fraction and not get decimals if you want. But that's a new, we don't teach that usually in at the Excel centers. We usually distribute and then work it out. But this way is actually more efficient. Okay. I'm going to erase this, but I'll wait. Does everybody have this? Kelly, did you get it now? Did you explain to her? Okay. I'm, am I good to erase this purple so I can do number 5 so it's not distracting us? Okay. Here's the eraser. Whee! All that work now gone. It's like when you clean the kitchen and then you cook again.
Or you leave the house and you come home.
I know. You know, someday the adult children will leave, and when I leave my house, it'll look exactly the way I left it.
My youngest don't ever want to leave.
Mine don't either.
I want to stay with you, Mom. And now he's almost 19. I still want to stay with you, Mom. Like, I love you. Pick up after yourself.
I oh wait, there it goes. Okay, let's do this next one. Okay, where's the vertex? In, on, or outside? Outside. We did this one earlier. It's really easy to find. No, I can't find this arc that way because it's cut. So I'm going to just make this X, right? So in this case, I would do 1/2 Uh, oop, I forgot. 45 equals 1/2. And then it's x, and I forgot already. Is it plus or minus? It's going to be minus 61. So you could either clear the fraction by multiplying by 2 first, or you could distribute the half. Those who like to multiply by 2 first, go ahead and do that. I'm going to go ahead and distribute the half for those who don't like to do that. So I'm going to multiply this half throughout the whole parenthesis, right? So 1/2 x is just 1/2 x. But what's 61 times a half, or 61 times 0.5? 30.5. Now instead, I'm going to add to both sides.
Oh, because I didn't put the half. No? Because that marks it off.
Right? And multiply by 2. Because 1/2 and 2 cancels that out to 1. So multiply by 2. 75.5 times 2 is 151. Right? Now, the other way to have done it would be just to have multiply by 2 right away. This is just another way to do it. If I multiply by 2, I get 90 equals this 1/2 and 2 cancel, and I'm left with x minus 61. If I add 61 to both sides, I get 151 is equal to x. So either way works. It's just whichever. Yeah, I think this way is a lot easier. No decimals. But I show both, and it's up to you which way you want to do the work. Okay. Exactly. Can I erase this, or are people still writing? Good? Okay. Whee. Now, look at number 6. How are we going to set that one up? Oh, I have one number. Oh, boy, it doesn't erase very well.
360 minus 55.
Nope. 55 is the answer.
55 times 2?
Nope.
55 times 2. That's what I said.
If I call this x right here, I'm going to call this x. What can I call? Almost 360 minus x. This outside is 360 minus x. Because it's the full circle, this part here is, I could say, is x. Then the other side would be 360 minus x. Now you set up the problem. So I'm going to have 55 equals, which is the bigger one? 360 minus x again, right? Yeah, you have 2 of them, because this one is this arc. This one is the second arc. So you get 55 is equal to 1/2 360. How many x's am I subtracting? Minus 2x. Now again, you could either distribute the half. Oh, you like the other right? Now she's like, I don't want to deal with those decimals. So I'm going to multiply 2 on each side to cancel out the half, right? And this would be 110 is equal to 360 minus 2x. So I'm going to subtract 360 from both sides. Subtract, not add. So you get negative 250 equals negative 2x. Divided by negative 2. X is equal to 125. Ooh, there is one of these on the test, so please star that. Make sure you know how to do these type. I don't try to surprise you. I just, yep. Yep. So if you're organized, it shouldn't be too hard because you are able to use your notes. But you have to actually take your notes and be here. Okay, I'm going to go ahead and hand out. Well, go ahead and take a break. We'll take our break early. I'll give you a 15-minute break because we got through stuff faster. I'm going to, be back at like 10:30, and then you'll practice. If you get done early, I'll give out the review too for the test that we'll have on Thursday. Yes.